right, we're going to solve inequalities that are polynomials. So we've done linear inequalities and we've done absolute value inequalities. So now we're going to do polynomials of higher degrees and inequalities. So when I look at this, what I see is that I have zeros at 2 and 3. But let's look at a graph of this to see how we're going to solve the inequalities. All right, so I type in my graph. Of course it freezes. Okay. Oh, whoops. Okay, x minus 2, x minus 3. And I graph this. All right, let's zoom in. Let's go to our window and adjust it a little bit. We can leave that. We're really not interested in like the whole thing. We're just interested in above 0. So let's see. So here we have an x, we have a 0 at 2 and a 0 at 3. And we're solving for when it's positive. So I can see here that it's positive. So positive means it's above the x-axis. So it's above the x-axis for 2 and left. And it's above the x-axis for 3 and right. I can also see this by going to the table. So remember that I'm looking for greater than 0. So if I go back this way, I see from 2, at 2 I'm at 0, and then as I get smaller, I'm positive. So the x values that are smaller than 2 are positive. Between 2 and 3, so there's a 0, I'm negative, so I don't want this part because I'm below the x-axis. And then for values larger than 3, for x values larger than 3, you can see that my y values are positive. So when I have x, or my function greater than 0, that means I'm looking for positive values on the y part. Okay. So I can write down my answer now. My answer is the values to the left of 2. So let me just sketch a real quick graph here. It looks like this. There was 2. There's 3. So values going left. So values left of 2 are included in the solution. And values to the right of 3. So over here, I'm above the x-axis. So that's values to the right of 3. Now, why is it the squares brackets? Because it's equal to. So I can include the values where the function equals 0. So that would be 2 and 3. So square brackets. All right, let's look at the next one. Okay, this one looks a little different. It's not factored, and it's not even less than or equal to 0. So that part I'm going to fix real quick. I'm going to move this to the other side. So remember that I can add and subtract without changing the inequality sign. And so there I have x squared minus 4x minus 5. Now, you may realize that this factors into x minus 5 and x plus 1. And so we would have zeros of 5 and minus 1. Okay, now we go to our calculator. And We're going to graph not the original problem, but the second one, the second equation that we got after we subtracted the 5 from both sides. So we're going to graph x squared minus 4x minus 5. And I'm going to graph that. Okay, now I am looking for less than 0. So starting here at 1 over to here to 5, I'm below the x-axis, so I'm negative, less than 0. We can also see this going to the table. You can see that negative there. At 1, I switch from negative to positive. So I'm negative, and now I'm 0, and now I'm positive. So look at the graph one more time. And now go back and write our solution. So I'm less than 0 from minus 1 to 5. And I use rounded braces because it's less than, not equal. There's no equal, so it's a rounded braces. And this one. Now I have 4 different ones here. Each one has a different sign. Okay, so let's graph this one. Okay. Okay, I think I got it all. Oh, it's not like that. Okay. So I graph this. What happens? So what's going on there? Let's go back and let's look at our graph again, or our equation here. This factors into x minus 2 times x minus 2, which is, x minus 2 squared. So this is an even multiplicity. Even multiplicity. So what that means is that it touches but does not cross. So how is that going to affect the answer here? So it wants the x's that are greater than 0. So the x's that are greater than 0 are all of them except here where x is, when the function is actually equal to 0. So it's all of the values to the left of 2, and all the values to the right of 2. Just not 2 itself. So that's how we would write that. Now let's look at it and see what happens if we change it from, so this was greater than 0 to just less than 0. And there's no values here that are below the x-axis. So this would be the empty set, or it may say no solution on your, as a choice on your list. So may say something about the empty set, or there's no 0, there's no elements in the solution. There's lots of different ways to say that there's no numbers here. Now, if I say less than or equal to 0, well, here at 2, I am equal to 0. At x equals 2, my function value is 0. And that's the only one. So this becomes this. So remember that when we have a single value, we use the braces for discrete values. So like if we have a list of numbers as opposed to an interval. So those are the curly braces, and that's the only value where this equation is satisfied and it's equal, the left side is equal to 0. And then when it's greater than 0, greater than or equal to 0, well, it's all of the ones to the left of 2, all the ones to the right of 2, and 2 itself. So it becomes, we do not have to exclude any values for greater than or equal to 0. So if we have a parabola whose vertex is on the x-axis, we can have one of these weird situations where you know, we're excluding one value, or all of them, or all but one, or none. Whereas if the vertex is not on the x-axis, then we have some type of interval that's, you know, not just, you know, this is a little, it looks a little different. You have to realize, so it's just, when it's the open circle, it's just one value that's excluded. All right, so that's it for this one.